Good day, everyone. My name is Marita T. Salandanan, a Doctor of Business Administration graduate from AMA University and currently an Assistant Professor at Emilio Aguinaldo College, Cavite. For the background of the study, why it was called blockchain. It was called blockchain because it contains block. Every block contains the hash of the previous block. A hash means random sequence of letters and numbers, just like a fingerprint, so it is unique. Every time you need to add changes to the block, you need to create a new block so no one can tamper it. The education industry falls on second generation of blockchain, which is smart contracts. As an educator, the researcher can help solve the issue of requesting documents from the school through blockchain technology. The following hypotheses were tested. Null hypothesis number 1. There is no significant relationship in the perception of respondents with regards to their awareness on the use of blockchain technology in higher educational institutions. Null hypothesis number 2. There is no significant relationship between blockchain technology as a competitive advantage in terms of cost and differentiation. For the sampling techniques, there were 3 sampling techniques used: purposive, quota, and convenience sampling. For the research instruments, the researcher made use of self-made survey questionnaire. For data analysis, Likert scale were used for SOP number 1 and SOP number 2. Frequency and percentage distribution were used for SOP number 1 and SOP number 3. For weighted mean, it was used for SOP number 1 and SOP number 3. ANOVA was used for SOP number 2 and SOP number 4. For SOP number 5, EduChain activity model flow was recommended. A total of 193 respondents answered the survey questionnaire. 18 were industry practitioners, 18 were professors, and 157 were students. Structured written questionnaire was floated to get the qualitative data from other respondents. There were 10 respondents. The results were used to support the quantitative data elicited from the survey questionnaire. For the summary, for SOP number 1, overall respondents are aware of blockchain. The only thing that varies is the level of awareness, with professors as moderately aware of blockchain technology. For SOP number 2, the null hypothesis is accepted. The perception of respondents is not significant with regards to their awareness on the use of blockchain technology in higher educational institutions. For SOP number 3, cost is moderately relevant and differentiation is relevant in terms of competitive advantage. For SOP number 4, null hypothesis is accepted. Overall, there is no significant relationship between blockchain technology as a competitive advantage over other colleges and universities in terms of cost and differentiation. Now, for the summary of SOP number 5, it will revolutionize the education industry in terms of record keeping, serve as a foundational technology in credentialing. Record keeping is efficient and available in real time, saves so much on cost printing papers, labor cost. It solves recurring issues of lost credentials, delay in processing of documents, and customer satisfaction will be greatly improved. Now, I will discuss to you in detail the 3 diagrams which I proposed. They are figure 3, figure 4, and figure 5. 3 for physical flow, 4 for logical, and 5 for EduChain activity model flow. Figure 3 emanates from the issuer or the school. Once deployed in EduChain decentralized network, it will be authenticated. External stakeholders like potential employers can verify and validate a student's digital certificate by accessing the EduChain. Logical flow has 2 parts: the signing, verification of digital signatures. data is converted to hash, number that contains ones and zeros. After it has been coded, it will be locked using the owner's private key and attached to the document itself. The digital signature will come from the registrar. Then comes the verification. Digitally signed document is still locked. To view the document, the student has to get the private key from the school by paying Ether to the school. Once done, the student share data will decode the private key by entering the signer's public key. Now, after using the signer's public key, the two hashes will be compared by the ABlockchain. If both hashes are equal, then the certificate is valid. Figure 5, or the ABlockchain activity model flow, starts from the registrar, where hard copy of credentials are scanned and converted to soft copy. However, before initiating transaction, a virtual wallet with Ether currency must be created so that all documents will be stored there. The Ethereum virtual machine uses Turing language based on C++ programming language. It initiates transactions using compilers. These compilers process smart contracts in which a private key from the registrar's virtual wallet is attached. Then it goes directly to the execution machine and passes through a virtual machine stack. A unique hash is created and stored into blockchain. Now, to view and share these credentials to potential employer, the student must request access from the school and pay them with Ether. Only then will the private key be given to get the verified digital certificate. A public key will be compared with a private key by the ABlockchain. If the hashes are equal, then the certificate is valid. Moving forward to SOP1 conclusion. For SOP1 conclusion, overall respondents are aware with a weighted mean of 3.57. With accessible and paperless school records, one can truly imagine that soon this technology will be dependable and indispensable. The best part of blockchain technology is it is stored in the blockchain, which means that in any event that we cannot control, like typhoons, fire, war, earthquake, and other similar catastrophes, school records are still safe in the blockchain. For SOP number 2, the results show that the null hypothesis is accepted, which means that there is no significant relationship in the perception of respondents with regards to their awareness.